Okay, we start again. So we have looked at the general introduction to architecture. We have looked at physical architecture. Look at the intuitive definitions. We have looked at short history on the structure of the structure concept in software engineering, and we have considered some software architecture definitions, including yours. Now, why all this? Why this software architecture design? Rationale, the motivation for software architecture. Why do we need it? Okay. So what's the rationale? Why do we need software architecture? I want to have some answers from you. Probably also the motivation why you follow this course. So, why do we need software architecture? Actually, it was in some of your definitions. To organize the code, the whole software development process. Right. It's not only the code, okay. Okay, what else? You had something about project.
To make the project in short time and design it well.
To manage the project, right? What else?
See what part is dividable and what part is not. How we divide the project and how we build them together.
Okay, the project management. Again, is related. Work allocation, you mean?
To create reusable components.
To define reusable components. Right. For reuse. Some others. To maintain software. Good. Let's look at them. Some of the key motivations, which overlaps with what you said. Actually, the first one is abstraction. Abstraction is what's the abstraction is the it's an important process when you design software. This is from Grady Butch books. There's an old lady. This is the ATM, but she has one abstraction: just press the button or not. But she is not aware about the complex wiring, right? So, in abstraction, we focus only on relevant details. In our case, externally visible properties of components, and we ignore the details. Software architecture has actually the highest level abstraction. This a car architecture, it can be very detailed, but we could actually abstract from it and say this is the conceptual architecture. Who said that? What was the conceptual? Yes, conceptual structure of the car, which means that so a car consists of 4 components. It's an abstraction. You have a chassis which carries the engine. The engine rotates the wheels. Chassis carries the wheels, carries the brake, and then brake stops the wheels. Okay. It's a very conceptual structure, high-level structure of the concept of car. The car itself is quite detailed, very complex, but we abstract from it. And software architecture actually represents the high level, the highest level abstract specification. Well, typically we can see this is subsystem, so architectural level. Below that we have detailed design, object-oriented design, detailed design, and even lower we have code. Just the code level, the Java programs. Abstraction. Why is it important? To cope with complexity. We don't want to view everything, right? We just want to see the gross level structure. Abstraction helps to cope complexity, but also improves understanding. Okay. So that's second, stakeholder communication. When you design software, you have multiple stakeholders. Other stakeholders are persons, entities who have some interest in your system. Example stakeholders could be end users, managers, developers, testers, reliability engineers, analysts, detailed designers, okay, project manager, etc. Okay? And all these persons have some stake, some interest in your system. The architecture can be considered as a common medium, a common model for communication among these stakeholders. Okay. You can just say this is the architecture, and together with all these stakeholders you can communicate. So architecture is the medium for communication. It helps to improve the communication in your project. And as such it will improve the understanding of the system among the stakeholders. Imagine you would not have such a common medium, how would you communicate? Okay? That would be very difficult. You just say this is our architecture, and the manager, the tester, developer, they can just look at the architecture and then communicate, which is important. Third one, cope with evolution. Usually after development the system has to evolve because the requirements changes. About 80% of the cost of software systems occurs after initial development. So software systems change over their lifetimes, we could very often, if not we could say always. And changes can be categorized, so it can be local, non-local. Local means to change to a single element, non-local to multiple elements, and architectural which are more systemic, global changes which affects the overall structure. Well, architecture can help to cope with evolution. How? Architecture can define what should be stable and what should be adaptable. So it defines the boundaries of adaptability, the boundaries of evolution. Okay? And it can also anticipate on this evolution. If you have a proper architecture definition, then the changes will only be within the architectural abstraction boundaries. We also say architecture provides balance between fixed and adaptable properties, adaptable parts, components, connectors of the system. There's nothing permanent except change. And architecture defines what should be actually more stable, but also defines what can be adaptable. So it also defines the limits of the evolution. This was in one of your definitions. Architecture helps to guide software development process. That's true. So this is just any process, and very early in the software development process life cycle, you have some an architecture. The subsequent phases, processes in the life cycle, they are based on your architecture. So architecture can also be used to guide the process, to guide the analysis and design, to the detailed design, to guide the programming. Okay? So it can guide the development process, but also it can guide the development project. That's what you said also, what some of you said, okay, about you can manage the project. If you have architecture, software architecture, you can more easily manage the software project. How? Well, architecture can be used to define the work allocation teams. Division into teams, units for budgeting, planning. Okay, you could say could be based on the specific architecture components, base of work breakdown structure, organization of documentation. So your whole system can be just documented based on the architecture. Basis of integration is very important. Okay, you could have multiple external components. Architecture could define the common structure for integration. The basis of test plans, testing, basis of maintenance, and for incremental deployment. Okay? So it can help also the development project, the process project. Finally, that's what you said. So it can help for large-scale reuse. Software architecture is abstract specification, like here, this is abstract specification of cars. In essence, it represents a set of systems, and actually software architecture by itself is a software asset or software product that needs to be developed. If you are developing the same kind of applications, it makes sense to reuse this gross level structure, to reuse the software architecture. Okay? And this can also lead to the notion of software product lines, which is actually another course, and we talk about software product line architecture. But by itself, so reuse, cross-level reuse software, it's important. Okay, wrap up. Rationale. Why do we need software architecture? It's abstract specification, so it provides improved understanding. We don't need to bother about the details, internal details. It's a vehicle for communication, architecture, and all the stakeholders can communicate with each other based on the architecture. That's my phone, excuse me. Sorry. Should not have one. I thought it was on silent, but okay, can happen. So, understanding communication, it's a manifestation of earliest design decisions, and as such can help to cope with evolution. It guides the software development process. Using the architecture, we can guide the detailed design, the programming. It supports the organization of development project and provides gross level reuse. Any other motivations that you can give? So these are one of the key motivations. So it's clear. Obviously, if we take these 6 points only into account, then we can see how important software architecture is. Right? There are also some misconceptions about architecture. One of it is that it's only a layered structure. It's not. You could have also architecture in which you don't have layering at all. Layering is just one architectural style or one view. But you could have another dominant decomposition. We will see that later on. There are some misconceptions. So architecture is just paper. Okay. You say, oh, it's just on paper, it's not in the system. Okay. But in essence, so every system has an architecture, whether it's visible or not. Even the simplest systems have an architecture. Maybe it consists of one component, but it has an architecture. If you have larger systems, definitely it has a more complex architecture. The architecture eventually also resides in the code. Okay, the code is structured in some way. Okay, so it is there, and we can make it more explicit, and we can and control it. If you don't do, you cannot control. So architecture is not just paper. Architecture is also in the system. There's some confusion about the relation between architecture versus design. What is design? What is architecture? There's large discussions about that. But in essence, we can say, so if we categorize all the designs, we have design. Architecture design is design. Detailed design is also design. So architecture is design, but not all design is architectural design. In essence, architecture focuses on the gross level view of the system, okay? The systemic view, okay? Not on the detailed issues. So in that sense, it's at the highest abstraction level and focus on systemic, significant design decisions. As such, we say, so whereas detailed design, it's at the lower level than software architecture. Sometimes you have multiple levels, so then the term becomes relative. What is software architecture? Then software architecture for one team could be detailed design, for the other could be just the architecture, the gross levels architecture. Okay? So if we talk about software architecture, we mean actually the highest level design. Gross level structure, defining the gross level structure of the system. Architecture versus infrastructure. You also see this a lot. Say like, okay, infrastructure is important. So how you deploy your architecture to the nodes, hardware nodes, is, for example, infrastructure. But its architecture is more than that. We will see that this can be one view, architecture view. Okay? So infrastructure, you could have architecture view which describes the infrastructure of the system, but it's not just the infrastructure. Architecture is more than that. Architecture versus technology, you also see this. So the network is the architecture, they say, or G2E is the architecture. These are just technologies. They serve to implement your software. In essence, also, very often, you want to be actually independent of these technologies. You want to be, sometimes, as we say, also platform independent. Okay? Architecture is not technology, but the technology is a means to implement, to realize architecture. Architecture versus structure, we said it's the gross level structure. Actually, lots of research has been focused on that also, and also textbooks focus on that. But not architecture is also more than structure. First of all, not every structure is architecture. Like not every design is architecture. But besides of that, architecture also includes, as we saw also in some definitions, design principles, the behavior, how the components interact, okay, at the high level structure. So it's architecture is partially structure, but also behavior, design decisions, constraints, etc. Okay. Architecture is flat, one could say. So that's the people's. This was actually several years ago. If you have simple system, they say architecture is flat, which means that you have actually one view, one architecture. But currently we know, especially with the work on architecture views, view modeling, that architecture has actually multiple dimensions. And one view is not sufficient. Why is that? We will elaborate on this later on. Because, as we said, we have multiple stakeholders, and each of these stakeholders can have different concerns which require different views of the architecture. And so if we are dealing with large complex systems, usually we need more than just one view. We need multiple views. So the misconception here could be that architecture is flat, that you have just one structure. Another one, architecture versus art. What people tend to say is just it's a matter of art, Fingerspitzengefühl, we would say in German. There are no strict rules for doing that. It's just a matter of the creative thought. So it's a kind of art. Okay? I think this is just a misconception. Architecture design is a rational activity. There are some steps, heuristics that you need to follow to design an appropriate architecture. In that sense, it is not art. Of course, it might require some creativity to, for example, combine several architecture patterns to solve the problem. Okay? But in principle, it's not art. It's a systematic, rational activity. These are some of the misconceptions. Architecture is just paper, design, infrastructure, technology, structure is flat or is art. Some of them are not true, some of them are partially true. And we could add here another misconception. Architecture is just a layered structure. Right? That's also a misconception. There are several other misconceptions, but we can see a lot. Did you have one of these misconceptions before about architecture? No misconception here. Okay. Good. Any questions so far? That's everything clear. Software architecture in life cycle. Where is software architecture? Okay. Well, typically, software architecture is one of the earliest phases in the life cycle. Imagine we have just some life cycle. It's not important what kind we have. I'm not also indicating here waterfall life cycle, but just a set of phases, workflows that we have in the software development life cycle. Typically, these workflows: requirements analysis, design, implementation, testing, etc. You could have waterfall, iterative, whatever. So where's architecture design? Actually, we say it's early in the life cycle. It's just after requirements analysis. We should have software architecture design. It's not late on, it's not here, but early on, before the design. The earliest artifact, one of the earliest artifacts, which defines the gross level structure of the system, and where you define also the key design principles. Okay? So and we focus on that. Actually. In object-oriented design course, you focused here. Okay, how to do detailed design. In programming course, Java, it's here. And we have now shifted the abstraction level. Okay. So what does it mean to realize then? So then you go here. You go to do further detailed analysis, detailed design. From very abstract perspective, it's like this. So requirements analysis. If we design, we get the software architecture design, and we realize, come at detailed analysis and design. And there's also evaluation of software architecture. In essence, in this course, we will focus on how to design architecture, which means how to model, how the patterns the architecture views. We will shortly look at how to map architecture to detailed design, and also look at how to evaluate. Okay? So that's the, if you have questions, you can just ask. Questions are important. If you want to ask in Turkish, just ask. Şey olmasın. You should not. I think the course is also important, right? Influence on software architecture design. This part is about, so what defines, what influence, what's the impact on the software architecture design. We are going to design the architecture, but you are not actually, it's not a freely activity. So it is bounded, it's shaped by some forces. Okay? We look at these forces here. One of the important forces are, of course, the stakeholders. In the system you have different stakeholders which have different concerns, like manager concern as low cost, work allocation, end user wants functionality, behavior, maintainer wants adaptability, tester testability, etc. This is the poor architect. The architect must identify all these stakeholders, the important stakeholders, identify their concerns, okay, and based on these concerns define the architecture. So all the stakeholders have a direct impact on the architecture, software architecture. And all the concerns are, of course, balanced by the architect or architecture teams. We also call these architectural drivers. The architectural drivers are typically derived from the architectural stakeholders, which have some concerns, which we can classify basically as high-level functional requirements. What should be the functional requirements? Technical constraints could be business constraints, and some requirements related to quality concerns, quality attribute requirements. Or people also say for non-functional requirements. Each of these have a direct impact on the architecture, and it is the role of the architect to balance these concerns, to optimize these concerns, and define a proper architecture which meets these architectural drivers. Okay, so it's not, you cannot say that architect go and design the architecture. So it should take into account the architectural drivers. So it's not a one-man decision. Okay, so that's the first influence on the software architecture. Organization itself has also an impact on the architecture. Both the structure and the nature of the organization. For example, if your organization consists of programmers which have seen are skilled in client-server communications, or we could say layered architectures, then typically they would design such a client-server architecture or layered architecture, right? So the organization, the structure, the persons, the staff skills, they have a direct impact on the architecture. Also the development schedule and budget. Because architecture, you define also the cost of the system, right? You could design a very reliable system. You could define it at architecture level, but this might also include a higher cost. But the organization can say no, it's too high, so it can have direct impact. Further, the goals of the organization might impact the architecture. They could say, we have invested on the existing architecture, we would like to reuse that. Okay? Can have direct impact on the architecture. And organization can focus on specific products which needs to be reflected in your architecture. So, stakeholders have impact on architecture, organization have impact on architecture. The background of the architect itself and the experience has, of course, an impact on the software architecture. The software architecture will use best practices and avoid approaches that did not work on earlier projects. So the more experienced an architect is, the more appropriate the architect's definition can be. That's the assumption. Okay. If the architect is not that experienced, it will have also an impact on the software architecture. It's quite easy, right? There's the related to Conway's law. Ever heard about this? Conway's law. This is a law presented by Melvin Conway in 1968, which says organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. Or simply stated, the structure of software reflects the organizational structure that produced it. So this is an example. You have a company X consisting of 3 groups, E1, E2, E3. This is the interaction pattern between these 3 groups. And if the Conway's law would apply to this company, then typically, if they would design a system, the structure would be like this. Okay. So that's the organization in this perspective has a huge impact on the architecture, and could even on the interaction patterns. So you should be also aware of that. Even an architecture might lead to a new organization structure. Okay. But there's always a force also of the organization structure on the system, on this software architecture. Okay. This is the extreme case, of course, but there's always some impact. Environment. Architectures are influenced by technical environment. What's that? Might include adapted tools, the standard industry practices, or software engineering techniques. Okay. They all impact the software architecture. Summary. Architecture is influenced by the requirements, which are derived by the stakeholders, which we call architectural drivers, the structure and goals of the developing organization, available technical environment, and the background and experience of the architect. These are the issues have direct impact on the architect and architecture. So in that sense, if you look at this, what's the role of an architect? It's not just a technical person, but it requires a person who has, a very mature background, but also has some skills about diplomacy, negotiation, and communication skills are essential. So typically in companies, they also don't, if they are looking for architect roles, they don't just look for the smartest guy, but also for the persons who have good communication skills. But if you have good communication skills and no background, you are also not a good software architect. So you need both. So it's a sophisticated role. The architect. There's also influence vice versa. So these are the impact, the influences on the architecture. But the architecture itself can also impose has influence on for example, the organization. The architecture affects the structure of the developing organization. Can affect. Why? Because what did we say? One of the motivations for having architecture is, for example, work allocation. Right? Architecture defines the gross level structure, the components, and in that sense, the architecture, defining the architecture, could require to restructure the development organization. Because it could say, so the units, the components, could lead to a new units in your organization team. The architecture can also affect the goals of the organization. It can, for example, a successful system built from the architecture can enable the company to establish foothold in a particular market. It can provide opportunities for efficient production and deployment of similar systems. Once you have an architecture, reusable architecture, you can see some opportunities to develop similar kind of products. So in that sense, it can affect the goals, and the organization might, as such, adjust its goals to take advantage of the newfound expertise. Architecture can also influence the requirements. So stakeholders' concerns impact the architecture, but architecture can also affect the requirements. How it can either, for example, an existing architecture can lead to so you can talk to a customer, and then the customer could say to relax some requirements which are not in the existing architecture. Okay. So that's the part. So it's continuous communication with stakeholder. If you have already existing architecture, or you have designed a proper definition after communication with several stakeholders, then you communicate and interact with the stakeholders, and this might impact also their decisions. Architecture will also influence the technical environment, because proper architecture might require some standard industry practices, architectural patterns, tools, and software engineering techniques. To sum up, actually we have a mutual influence. It's not just one direction, but mutual influence. Several factors influence the architecture, but the architecture also influences these factors. It's a cycle of influence. Architecture is implemented in the system. System can have also direct impact on these factors. Okay? So let's summarize the whole thing. Software architecture design plays an important role in structuring software. Several software architecture design definitions have been evolved over the years. We have considered some of these definitions. We have looked at some stable definitions. We have now quite a mature understanding of the concept of software architecture. Also, we see a specialization of these different concepts. Software architecture represents, in a very abstract way, the high-level abstraction, cross-level structure and behavior, and as such helps to improve understanding of the system, supports stakeholder communication, guides subsequent software development process, supports organization of the project, and by itself provides gross-level reuse. Software architecture is influenced by stakeholder requirements, organization, technical environment, and the experience of the architect, and vice versa. We have also looked at some misconceptions, but that's it for. So far, the introduction of this course. For Wednesday, we will start with modeling, architectural modeling. Any questions about this part? It's clear, so if I say, why do you follow this course, now we should have more a convincing actually argument then. Right. Okay, then that's it for today. Thank you for listening. See you on Wednesday.